Something happened with your RAID controller, and now your disks are showing up as totally blank. What happened, and how to fix that? Coming up! So just a quick disclaimer, this failed in a particular way that's specific to Dell and HP RAID controllers. There are other RAID controllers out there that'll fail this way. I'd recommend that you try partition recovery software and that kind of thing before doing this. This was really kind of a Hail Mary pass, but hey, it's an adventure, so, give it a shot. I wanted to share with you one of the more esoteric things that we do. So this video is about recovering data, which in this case is from this thing. This is part of a RAID array, a RAID 1 array, so it's not anything complicated. But what happened was the RAID controller spazzed and deleted the container, and that action sort of blanks the disk. And so it's like, well, how do you recover from that situation? Well, there's a couple of different ways. There are different tools for doing recovery. Sometimes you've seen partition recovery and things like that. But if this video gets 100,000 hits, then maybe we can have a camera guy follow me around and share more crazy stuff. So you should be watching this video if you have ever worked on like Dell or HP enterprise gear and you've got a controller. This is an older controller. This is a Perk 6, I think, 6i. The new controllers from Dell and HP that are really just rebadged LSI controllers, even the IBM controllers, they do funny things sometimes. And this will hopefully serve as, if one of those does something really crazy, you can recover it. Now this also, we're going to be working on a single drive and a standalone machine here, but if you had an array, like a RAID 5 array or a RAID 6 array, all of the stuff that I'm going to show you would still work. You would just have to operate on the array on the controller instead of putting it in another machine. So take that for what you will. So this drive right now is completely blank. It's completely full, 2 terabytes of information. Of course, the person that has asked for a rescue mission here has no form of backup. They just, sort of wandered in with, mortal gunshot wound to the face, and they're like, hey, can you patch me up, Doc? And it's like, I don't know. We gotta figure this out. Let's just go ahead and plug in our drive. Patient 0. And then we wait for it to boot up over here. Alright, we're in Linux. Ubuntu, to be precise. Alright, so this is just, we can ignore that. There's our drive, look at that. Like, alright, disk identifier, all zeros. There's nothing here. Doesn't contain a valid partition table. Dun 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 dun. So that's a pretty common thing. The partition table is just the first 512 bytes of the disk. So not really anything big. If we do test disk, which is a handy, awesome command, we can run that on SDB. Yeah, it's Intel. Just analyze it, it's fine. Let's do a quick search. So that's going to look for stuff on the disk. As you can see, test disk, not going well. It's like, there's nothing here, everything is gone. So it turns out that what has happened, or what we will discover, I think, is that both the 512 byte boot sector is gone and the start of the partition is gone, which is awesome. So we can try a deeper search, but it's not going to find anything. Yeah, close enough. Alright, just suffice it to say that I let it run before doing the video and blah blah blah. So I already know how this is going to play out because I've already fixed it, and this is our backup clone. And this is one of the more insane things, so I just wanted to show you guys. So, alright. So there's not really, test disk is not really doing us any good. Now we can write the MBR code, but we don't have a valid partition table, so that's kind of rough. So I'm going to quit here. Now let's do less-f dev sdb. So let's take a look at that. Oh, look at that. That basically means the beginning of the drive is all zeros. So I'm just going to page down through here for a little bit. Yeah, this isn't good. Looking pretty bad. Alright, let me show you another command, strings. Oops. Strings is awesome because it finds things that look like strings. So clearly we can see there's still some data here. Oh, look at that, HTML files. That's good. So there's a file system here. This is reading in part of the NTFS MFT. I knew it was NTFS. So, you know, there's that. And there's some GIF files and God only knows what. So anyway, and then sometimes strings doesn't know the strings are nonsensical. But so this tells us that there's stuff that's still here. So that's good, right? The first thing will be to, let's fix the MBR. I'm going to use DD to make a copy of the first 512 bytes of the drive. So what DD does is it takes an in file, which in this case is the /dev SDB, which is this physical hard drive, and the out file is going to be the original boot sector.bin. Block size is 512 bytes and the count is 1. Now I just happen to know that the boot sector is only 512 bytes, so not really a big deal, and count 1 is only going to do it once. So we're going to do that, and we're going to do that, and then if I do less original boot sector.bin, ta-da, but see, there's nothing here. It was all zeros. So this hasn't really accomplished much. Now, through trial and error and, you know, basically how Windows would by default lay out a partition. So another identical 2 terabyte drive, we basically let Windows format it the way that it would on another drive. As terms of like partition alignment and things like that. If you have an old backup, even like an ancient backup of the system in question, you could use that backup to see what the original boot sector was. So if I do, let's do fdisk on the disk that's working here. Alright, so this is really the information. This table of numbers is really pretty much all you need to be able to recover the partition table in this case. It doesn't get us out of the woods as far as data goes, but it's the first step. And you really need to know the start cylinder and the end cylinder and how many blocks it was and blah, blah, blah. So I'll just guess and say that the beginning was 2048 and the end was basically the end of the disk, because that's Windows defaults as single partition. This is not a boot drive, this was a data drive. If this was a boot drive, it would be slightly more elaborate. You might have to go through Windows setup on a blank version of this drive. You don't want to be doing these operations on the drive that contains the data. You want to be doing the operations on an identical drive that does not contain the data that you want to recover, so you can see what Windows does by default or Windows setup. So in this case, we just had to pop in another identical drive, Seagate Barracuda 2 terabyte drive, and just let Windows format it. This is a little trickier if you're doing an array, because you have to have an identical array, and then you have to set up that array in a machine that already has Windows Server. So you may be looking at a significant time sink to do the type of operations that we're talking about. But if you have a backup, even a really old backup, your partition layout is not changing. Even if you only have a backup from like 1273 AD, that will totally save your bacon here, because the partition layout will not have changed in the life of the machine. So I'm going to quit here. Yes, this looks more like, I've just lessed it. This looks more like a boot sector like I would expect. So enter DD again, if equals /dev / oops, nope. We want good boot sector.bin, OF equals dev SDB, count 1, BS equals 512. Oh, you don't really need that because this file's 512 bytes big. It's just a good habit to get in case you do something wrong or you have a typo, and you know, the damage is kind of limited. Because remember, we've got that 512 bytes backed up as well. Yay, surgery. All right, -L, but we haven't reread the disks, but it doesn't matter. It's like, oh my God, look at that. Oh, it's a thing, and it makes sense, and stuff is happening. And so this is, you know, telling you start 2048, guessed correctly. Wasn't a boot drive, which makes sense because it's not. It wasn't in the original array. The boot flag is not set. You could actually use fdisk. If you knew these numbers, you could just run fdisk /dev /SDB and do new partition start 2048 end and then the numbers. If you knew the numbers, you could also take a guess at it. It's like, well, I'm pretty sure it's going to start at 2048 and the end is probably going to be the end of the disk, and it's probably not the end of the world if I don't get the thing exactly right. So, woohoo, look at that. All right, everything's good. So now I can get to /dev SDB1, right? And so everything's good. Well, sometimes. In a best case scenario, I have just very verbosely shown you how to recover the boot sector and partition table, but most of the time that's okay, but a lot of the time that's not enough. So let's less db1 db. I have to get the kernel to reread the disks here. There we go. Alright. And so, oops, I don't want to F-disk it. I want to less it. Alright. So this is kind of messed up too. Damn it. Alright. Strings. Okay, so that's good. Windows, this looks like stuff is here. But the first part of the disk is messed up. It's all zeros again. Why is this happening? Why is this happening? Alright. So, at this point, we gotta go look up some stuff on the internet. We knew this was an NTFS partition, and the NTFS partition has been destroyed by the controller because the controller is a piece of crap. Partition layout. Alright, so we know that NTFS uses the MFT to keep track of files, and the question is the MFT damaged? Well, probably not, because there's a bunch of copies of the MFT, and it's sort of spread out all over the disk. It's not like FAT, where FAT could be completely damaged. So I found this article on Microsoft's website, which is a really nice article, an explanation of how the partition, how the NTFS partition is laid out, and what where things are. And this is really cool because this is showing you the layout of the partition. And so it's like, well, the first 3 bytes are this, and the next 8 bytes are that, and then 25 bytes is this, and then 48 bytes is that, and then 426 bytes is this, and then 2 bytes is that. So, yeah. Then this is showing you the rest of the layout. Clusters plus MFT record, so you got 4 bytes, 8 bytes, things like that. These are the variables that have been destroyed by the controller, because remember, we looked at the beginning of the partition and it was all zeros, and this is showing us the typical byte values. And because we know it's all zeros, we don't know what the variables should be, but we do know that these are not what they should be. So because it's all zeros in the list over there. So if we go back here and we see the beginning of the thing is all just is madness. Now if we compare this, remember we've got the other hard drive in here, which is just your standard issue. Honestly, it's probably Windows XP, which is a different version of NTFS. But if we do less-f/dev/sda1 C NTFS, we get the NTFS signature, and we got all this stuff going on. There are variables to do with the file system here that are specific for the other drive that's in the system. And so we can go back to our handy dandy other machine and pull off the MFT record, because if you look at this, a lot of this is like, where's the log file, contains information about the volume, such as the volume label and the volume version, the attribute, the root file name index, cluster bitmap, boot sector, bad cluster file, security file, uppercase table, NTFS extension file, and some other information. And that's not necessarily, it's not quite 512 bytes. This part of it, this part is the 512 bytes. So what I'm going to do is the same way that we use DD to surgically extract the first 512 bytes of the partition, we are going to use DD to extract, to the first 512 bytes of the disk, we're going to use DD to extract the first ever how many bytes of the partition. Now I think, based on this documentation from Microsoft's website about NTFS, that 512 bytes is too much, but they probably padded it, so it's probably okay. And the other layout is 512 bytes. So I'm just going to grab 512 bytes and hope for the best. See, this is the boot sector section on an NTFS volume. We have already grabbed this. This is guaranteed 512 bytes. This is the partition layout, which is also hosed, and this is an NTFS specific thing on the partition. So this part, we recovered the partition. This part, we've recovered the boot sector and the partition layout. This part, we actually need to recover the partition. So, because it still doesn't work. If we just try to mount it, it's like, I don't even know what's happening. Wait. Yeah, it doesn't know. There's nothing there. It's like, what's happening? I don't understand. So, I'm going to go, and we need to add this up here. It's like, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, let's say 256 bytes. I'm going to grab 256 bytes off of the other partition that we had laid out earlier when we formatted it. Formatted a blank version of this disk in another server. I'm going to grab that 256 bytes and apply it here using DD. So let me go get that. All right. Now after finding a little bit of trial and error on the NTFS formatting parameters, when you format the partition on the other machine, we've got our 512 byte bin file, and so we're going to look at it and see it looks a little bit more like it should. NTFS, read errors occurred, blah blah blah. The variables that we were looking at back here on the Microsoft documentation have to match the file system that got destroyed, and so this may take you a few tries in your other machine that you have set up where you're formatting the partition that you created when you set up the boot sector on the other disk in the other machine, a blank disk. It may take you a couple of tries, so you might format it, save a bin file using Linux, format it again, save another bin file, format it again, save another bin file, just to find what works. So we're going to do this. We're going to copy this bin file to the start of the partition. BS equal 512, count equal 1. So what we're doing is using DD to surgically graft the 512 bytes from the file system that matters, from this partition, SDB1, to the damaged NTFS partition, hoping that the MFT and the layout on the freshly formatted match the way that it was set up originally, which is likely that it would if all other parameters are equal. Like when you just right click on a disk, create partition, format it. What Windows did years ago when it was set up and what Windows will do today, it's probably the same thing. So, and this will surgically graft that while leaving the data alone. And remember that you can use DD to back up that 512 bytes as well, so you can undo what you did. So, all right, so that's done that. Now let's try to less and see if that looks more like it should. Yeah, all right, so that's got our stuff there. It was all zeros. All right, now let's try to mount it. Oh no, I must specify the file system type. All right. Oh my god, it mounted. And there's all the stuff. Look at that. It's amazing. And that's how it ought to be. So what did we do exactly? Well, the first problem was that the boot sector, the first 512 bytes of the disk, and the partition table had been lost. And so we pulled that off of another drive that was basically identical to this one. Same number of cylinders per track, same number of sectors, blah blah blah. We were banking on that if you had another drive like this and you set it up in a Windows machine, that the Windows would act the same way. So if you use the same version of Windows from the same era, that if you format a 2 terabyte disk that has these parameters, that it will do a layout like this. And so we did that using a blank, freshly, brand new blank disk, similar to the old one. And then we copied the 512 bytes boot sector, which had this partition layout. So the partition started at 2048 and ended here, and was this many blocks. And type 7 is NTFS. We knew it was NTFS. Like the person having the problem knew enough to know it was NTFS. So the procedure here might be a little different if it's FAT or something like that. So that recovers the boot sector and the partition table, but it was not enough to recover the file system, because then when we try to mount it, it's like, oh, it doesn't work. So once you've got the partition table in Linux, you have SDB, that's the device. SDB1 is this partition. And so when we looked at it, it was also blank. Whatever happened took out not just the boot sector, but also the beginning of the partition. And so Linux and other utilities like that were like, I don't see anything. There's not a partition here. Some recovery utilities would actually let you recover the files, the individual files from the file system, but most of them that I've encountered are either really expensive, or they don't recover the file layout. Like they'll let you recover the files, but you don't get the actual directory structure and layout. So you guys might know of a utility that will work that doesn't cost $11 billion, but I prefer to understand the file system and what actually happened. So then we did a little bit of research on NTFS to find out how NTFS works, and we see that most of the NTFS configuration stuff, like how many blocks per cluster and how many, what the media descriptor is and where the first MFT is and what the compatibility parameters are, those are stored in the first little bit of the partition. And so of course that's why the partition was not mountable. So once we figured that out, we were able to go back to our sister disk that's in Windows, that's a fresh out of the box blank disk, and pull the first 512 bytes of SDB1 off, and then restore that to this partition. And at that point we have an intact mountable partition with all of the data there, which is what we need. And so we were able to recover everything, and everything is just magical and happy from there. So this is some of the really insanely esoteric stuff. I don't imagine this is particularly useful to most people, but if you have a server and the server has absolutely crapped out and it's like, I don't understand, all the data's gone, how did it get rid of it so quickly? Chances are something like this happened, and you can use these techniques to feel your way around. Unfortunately, it's not a step-by-step instruction, and I'm sorry for that, but every situation is different. And so if you did not understand, or you wanted something that's more step-by-step, you're going to have to level up your understanding of how this stuff works, because these situations literally do not have a step-by-step solution. You have to sort of listen to the overview and then level up your own skills so that you can take this overview and apply it to your particular situation. So for the more esoteric stuff, this is Wendell. I'm signing off. I'll see you next time.